what do you do when you have integrals that involve the square root of a squared minus u squared, or the square root of a squared plus u squared, or the square root of u squared minus a squared? Well, one of the easy fixes, you may say easy, I think it's easy, is to use a trigonometric substitution. If you have one of these three forms operating within your integrand. So to use the trig substitution, you want to recall some facts from trigonometry. The substitution will be on this wise that we have one of three cases. Either it's going to involve a squared minus u squared, there we use a sine theta substitution, or it may involve a squared plus u squared, there we use the tangent theta substitution, or a square u squared minus a squared, there we use the secant substitution. You're going to build it based on the triangle. So here you're going to have a let statement, let sine theta equal to u over a, and you locate sine theta being u opposite over the hypotenuse, and then you can find the other leg based on the Pythagoras theorem. And the same argument for the tangent substitution and also for the secant substitution. Here are the three statements that I think are important in trying to form a substitution for the integration using the trigonometric forms. If the form involves a squared minus u squared, then you're going to use sine theta equal to u over a. If the form is u squared plus a squared, we're going to use tangent theta equal to u over a. If the form involves u squared minus a squared, then we use the secant theta equal to u over a. Let's start by looking at this problem here. The first three problems in the textbook, they tell you what substitution to make. Typically, when you're working problems on the test, you won't have this, but this is just to kind of help you get started. You don't need that because this problem involves 4 squared minus x squared. That's of the form a squared minus u squared, so that's going to be the sine theta. So we say here, let sine theta equal to x over 4. Now on the right triangle, we want to locate this. If this being theta, sine would be the opposite. Oops. Let's see. Sine would be the opposite of the hypotenuse. And so working the Pythagoras theorem, this leg ends up being the 4 squared, the square root of 4 squared minus x squared. So if that be the case, this implies that 4 sine theta is equal to x. Looking at this equation, we can find the derivative of both sides, so that gives us 4 cosine theta. Use the chain rule and take the derivative on theta, so that's d theta, that's equal to dx. So we use this dx representation to replace the dx there. Now we need to replace the x, we need to replace the square root of 16 minus x squared with some trig form. Now notice I think we get that directly from the right triangle. We have x over the square root, and that is tangent, so if you flip that, you get cotangent. Cotangent theta is equal to the square root of 16 minus x squared all over x. We go back to the integral, so this is the integral. This ratio here is cotangent theta, and the dx is represented by 4 cosine theta d theta. So this is 4 times the integral of the cotangent times cosine. Well, cotangent is cosine over sine, so this is cosine theta over sine theta times cosine theta d theta. This is 4 times the integral of cosine square theta over sine theta d theta. Now that cosine square is no more than 1 minus sine square theta. So we can write this as the integral of 1 minus sine square theta divided by sine theta d theta. This is 4 times the integral of 1 over sine theta minus 4 d theta, excuse me. Then minus 4 times the integral of sine squared divided by sine theta. I'll just write, write the whole thing so you don't get thrown off. Then the next step, we'll do the simplification. So this is 4 times the integral of cosecant theta d theta minus 4 times the integral of sine theta d theta. When we integrate this, the integral of cosecant, so 4 there, is negative 4 times the natural log of the absolute value of cosecant theta plus cotangent theta minus 4 times the integral of sine. The integral of sine is cosine, with negative cosine, so this is positive, negative times negative, cosine theta plus c. Now we would like to leave our answer like that, but we can't because the problem was given to us in terms of x. So when we just only use the trig substitution to be able to solve for what we wanted. So we need to represent the cosecant, the cotangent, and the cosine using the right triangle. So we have cotangent, that's the square root of 16 minus x squared over x. And we need, what did I say? Cosecant and cosine. So we need the cosecant and the cosecant and the, what did I say, cosine? Well, cosine, let's go ahead and get that from the, and I'm going to have to just write this right triangle down here because I can't see it. Okay. So what we have, the cosine from this right triangle, cosine theta is the adjacent divided by the hypotenuse, so that's the square root of 16 minus x squared all over 4. And then we need, we said the cotangent, that's the flipped version of tangent. So tangent is opposite over the adjacent, so the cotangent is the adjacent. So cotangent theta is the adjacent, which is the square root of 16 minus x squared all over the opposite. And then we needed cosecant, which is 1 over the sines. We just flip sine. So sine is the square root, excuse me, sine is x over 4. So the cosecant would be the 4 over the x. And so this is negative 4 times the natural log of the cosecant, which is 4 over x, plus the cotangent, which is the square root of 16 minus x squared all over x. Close that up, and that's plus 4 times the cosine, and the cosine, I got them all mixed up. That's the cosecant. That should have been, I'll be dang gone. Cosine and okay, oh, that's a 4 and that's an x. I'm blind. So the cosine here is the square root of 16 minus x squared over 4. And we can just write that as negative 4 times the natural log of 4 plus the square root of 16 minus x squared over x. And this is plus the square root of 16 minus x squared plus c. Let's look at the next problem. Here we have the integral of 1 over the square root of x squared minus 25. The form there is u squared minus a squared. So we say let secant theta would equal to x over 5. Well, if it's secant, well, that's the inverse of the reciprocal of the cosine. So cosine theta is 5 over x. And we can represent that on the right triangle. So cosine is the 5 over the x. And this side over here would give us the square root of x squared minus 25. So looking at the secant, take the derivative of both sides on that, and that would give us secant theta tangent theta d theta is equal to dx over 5. So I'll put the 5 over here. That's equal to dx. So we'll use this to represent the dx here. So now we need to represent this 1 over the square root. We can get that square root by itself by looking at the tangent. Tangent theta is equal to the square root of x squared minus 25 all over 5. So 5 times tangent theta gives us that radical by itself. So we come back up to the integral. This is the integral of basically dx upstairs. Dx is all of this. So this is 5 secant theta tan theta, and I write the secant theta tan theta, and I write the d theta over here. It's divided by that square root, which is 5 tangent theta. Well, the 5's cancel out, and all we have left is a secant. And just make sure all that's correct. The dx was the 5 secant theta tangent theta, and then the square root by itself was 5 tangent. That looks good. So this is the integral of secant theta d theta. Just seems like there should be more going on. Makes it look so easy. The integral of secant is the natural log of the absolute value of secant theta plus tan theta plus c. This is the natural log of the absolute value. Secant is x over 5. And the tangent is the square root. So this is plus the square root of x squared minus 25 over 5 plus c. And sometimes they like to write the answers with variations, like even the previous problem, they got rid of the negative in some kind of funny way. Who cares about that? But I will show you this one. This answer can be written as the natural log of the absolute value of x plus the square root of x squared minus 25 over 5 plus c. We can use the property of the natural log and write this as the natural log of the absolute value of x plus the square root of x squared minus 25 minus the natural log of 5 plus c, of which the natural log of 5 is a constant and c is a constant, so they all are summed up together. And so you can write your final answer as the natural log of the absolute value of x plus the square root of x squared. Mercy. X squared minus 25 plus some constant, of which the sum of the minus natural log of 5 plus c is still a constant. So here we have 1 squared plus x squared, so we use tangent. So let tangent theta would equal to x over 1. So tangent is x over 1. The hypotenuse is the square root of 1 plus x squared. Take the derivative of both sides here, so that gives us secant square theta d theta is equal to dx. So we'll use this to represent the dx. So then what about x by itself? We can just use tangent. X is equal to tangent theta. I hadn't said anything new. This is that statement there. And what about that radical by itself? Let's use cosine. So cosine theta is 1 over the square root of 1 plus x squared. If we do the inversion, so this implies that secant theta is equal to the square root of 1 plus x squared. So we have the integral of x, and so x here is tangent theta times the square root. The square root is secant theta, and dx is secant square theta d theta. Okay. So we're working with this. So let's see. Looks like we can use a u du substitution, because if u is secant, the derivative of the secant would be a secant tangent. Let's see if that'll give it to us. Let u equal to secant theta. This implies that du is secant tangent d theta. This is the integral. So if du picks up the tangent, du picks up tangent, and it picks up the secant, right? And so u would be secant here, squared would be u squared. So this is the integral of u squared du. So this gives us 1/3 u to the third plus c, but u is secant, so this is 1/3 times the secant cubed theta plus c. But now we have to use a substitution, back substitution on the secant. Secant was this square root, so this is 1/3 times 1 plus x squared to the 3/2 power, right? What about this one? Well, this one, they give us no instructions in terms of how to set it up, but I think we can factor out a 4, and this is the radical, the integral of the radical of 4 times 4 minus x squared dx. So this is 2 times the integral of the square root of 4 minus x squared. Now that's easy now. And I even question, why am I doing the easy problem and not Sorry, I thought it was something to it. This here is 2 squared minus x squared, so there we use sine. Let sine theta equal to x over 2. We draw our right triangle based on sine, opposite over hypotenuse, and this side here would be 4 minus x squared. So from here, we notice that 2 times sine theta is equal to x. Take the derivative, 2 times cosine theta is equal to dx. So we use that to represent dx. Now we just need to represent the square root of 4 minus x squared. Looks like cosine, some connection with cosine. So cosine theta is the adjacent over the hypotenuse. So 2 times cosine gives you what you want. So 2 times cosine theta is the square root of 4 minus x squared. So the problem that I'm working with is 2 times the integral of the square root of 4 minus x squared dx. This is 2 times the integral. The square root of 4 minus x squared is 2 cosine. And dx is represented by 2 cosine. Don't forget your d thetas. So this is 8 times cosine square theta, d theta. Now from the previous, why does it do that? It's the cuckoo caca that programmed this. From the previous section, said that if you have an integral involving cosine square theta by itself or sine square by itself, we're going to use the double angle representation. This is 2 times the integral of 1 plus cosine 2 theta all over 2 d theta. So this is 4 times the integral of 1 plus cosine 2 theta d theta. So we break this up. This is 4 times the integral of d theta plus 4 times the integral of cosine 2 theta d theta. Now this is 4 theta plus the integral of cosine is sine, but this has to be a u du. So let u equal to 2 theta, and du is 2 d theta, and so it's going to be a 1/2 du equals to d theta. There's a 1/2 factor happening in that one. So this is 4 times the integral of cosine u du, and the du divided by a 2, right, represents the d theta. So we get just 4 divided by 2 on the outside. So this is 4 theta plus 2 times the integral of cosine u du. So this is 4 theta plus 2 times here sine u, and just go ahead and replace what the u was. The u was 2 theta plus c. We have an identity from trig that says that sine 2x is equal to 2 times cosine times sine. So recall that sine 2x can be written as 2 times cosine x times sine x. So we get 4 theta plus 2 times this 2 is 4 cosine x sine x plus c. Now the cosine, you recall from the substitution, the cosine was the square root of 4 minus x squared over 2, and the sine was x over 2. Do you remember that? I didn't. Okay. So this is 4 theta plus 4 times the cosine, the square root of, I think I said 4 minus the square root of 4 minus x squared over 2. And then the sine was x over 2. Sine is x over 2. Yep. Cosine again was the square root over 2. Good. X over 2 plus the constant 4 divided by 2 will cancel out. Oh, the theta. Sorry, can't leave that as the answer. We come over here. Let's put that in red, and I'm getting hungry. And so it's time to get some goodies. So sine theta equal to x over 2. You always start with the let statement. So if sine theta is equal to x over 2, take the sine inverse of both sides. Then the sine inverse of sine theta is equal to the sine inverse of x over 2. Well, sine inverse of sine theta is equal to theta. That's equal to sine inverse of x over 2. Okay. So this is 4. I don't like red. Let's use black. 4 times this theta is sine inverse of, what was that? Oh boy. Sine inverse of x over 2 plus x times the square root of 4 minus x squared plus c. Right? 4 divided by 4 cancels. Write the x first. X times the square root. Okay. Don't mean to hold you long. Maybe one more problem, and then we're done. Okay. Then we get this. It's not a monster, but it's not Godzilla. But in the old Godzilla movie back in the 70s, Godzilla had like a little sidekick. I think it was Angarius or something like that. And this is not even Angarius. Godzilla had like the baby Godzilla. This is the baby Godzilla. The baby Godzilla, he tried to do like Godzilla. Godzilla would shoot out this fire, and the baby Godzilla would put out like a little puff, a little ring, a cloud, funny stuff. Anyway, Godzilla was my favorite monster when I was a little kid back in the 70s, man. And in my office here, I do have a Godzilla that my friends gave me. When I was doing ministry up in Pennsylvania. I don't know if you can see that. And it has a little button where you press it and it makes a sound, but the battery's dead. I'm going to get a battery for it so you can hear it. And hey, Godzilla was cool, right? Anyway, okay. So, okay, time is of essence. This is 4x squared plus 9. Think about that as 2x to be squared plus 3 squared. I have plus sign there, so we're using tangent. Let tangent theta equal to 2x over 3. Why? Look, this is the integral of 1 over x times the square root of 2x squared plus 3 squared dx, right? So we look on the right triangle. It's a bad right triangle. We locate tangent, the opposite 2x over the adjacent, right? And then we use the Pythagoras theorem, and we get the square root of 9 plus 4x squared. This is theta there. So from this let statement, take the derivative of both sides, and when I do that, that's going to become secant squared theta d theta, and then I'm going to say times 3 over 2 to get the x or dx by itself. 3 over 2 times the derivative, which gives us secant theta squared times d theta and that's equal to dx. So I'm going to represent the dx using this expression here. Now I need to represent x by itself. Well, look at the let statement again, and we can isolate x. So we have 3 over 2 times tan theta is equal to x. Now what about the radical? Looks like a combination of the cosine. So notice that cosine theta is equal to, it's time to eat, 3 over, hey, if you're smart, you just pause these videos if you need to and take a break, right? And then come back. I'm so sorry to make it so long, but I kind of want to just go ahead and just do it and get it out the way. You know, stuff that you kind of dread, you just want to just go ahead and just do it and be done with it. Well, it's this section, but it's cool though. It's not bad. So we flip this, and that gives us secant theta is equal to the square root of 9 plus 4x squared all over 3. But I just need the square root back in the integrand. So this is no more than just 3 times secant theta is equal to the square root of 9 plus 4x squared. I got to fix my lunch, eat it, and then go to Huntsville to a meeting by a certain time. Okay, I need this. So, yes. So I'm going to represent this, the integral. Okay, let's see what I got. Dx up top. So dx is this 3/2. And that was times secant square theta. Put the d theta over there. This is over x times the radical. Well, x is being represented by, what did we say? 3/2 tangent theta. And then the radical is being represented by 3 times secant. Okay. So the 3/2 cancel out. I have left 1/3 downstairs times the integral. That's a 3, right? Secant squared divided by secant. I have left a secant there, theta, all over tangent theta d theta. And the secant is 1 over the cosine, and the tangent is sine over cosine. Let's see what that gives us. So this is 1/3 times the integral of 1 over cosine theta all over sine theta over cosine theta d theta. Did I have breakfast this morning? I don't think so. Cannot recall. Oh yeah, nasty bagel. Anyway, let's look at that. This is 1 over cosine divided by sine over cosine, right? So, and since I'm hungry, it's like my mind is not even working, so I can't even just do it in my head real quick. So, well, this is divided by, so we'll say times, and we flip everything, and so this becomes a cosine theta here over sine theta d theta. The cosines cancel, so we have left 1/3 times the integral of 1 over sine. You can just write that as cosecant, right? Theta d theta. And the integral of the cosecant is negative. This is a 1/3 there. Natural log of the absolute value of the cosecant theta plus cotangent theta. Y'all better learn all y'all trig identities, folks, for the derivatives and the integrals, okay? Because I'm telling you, I'm watching you. One of my Christmas Sprite commercials. Anyway, okay, so now, cotangent. Oh, the time is of essence. Cotangent, is that cotangent? Yeah, cotangent and cosecant. We need those guys from the right triangle. So if tangent is this, so cotan theta is 3 over 2x. And then for cosecant, we need the sine. So if sine is 2x divided by the radical, then cosecant theta is the radical divided by 2x. Scroll down and see if we still see that. I don't, but anyway. So this is negative 1/3, negative freaking 1/3. If my left hand would just do right, times the natural log of the absolute value of cosecant. Cosecant is that square root of 9 plus 4x over, was it 2x? Yes, 2x. And then the cotangent, where is that sucker? I'm going to get you, sucker, plus 3 over 2x. All right, close that absolute value up, plus c. And, oh, just write it one more step. Who cares, right? I do not. Well, Weber sign might, but if you have issues with Weber sign, just email me. Because sometimes your answer is right, but it may not be in their form. We write this as 3 plus the square root of 9 plus 4x squared. Sorry about that. There's a square there. Did you say that? I heard you say it. Thank you. This is all over 2x plus c. Now this is fine. You could have left it like this, and I'm okay with that too. They're all the same. Thank you.